So we have discussed about the introduction. Yes. So in that introduction, what we have discussed about the things, the matter around us. Okay, what is matter? The matter around us. What does it made up of? Okay, definition of matter we have discussed about it. And yes, matter is defined as something which occupies space and possesses mass and offers resistance to any stress applied on it. So we have discussed about the matter by giving so many examples like things around us. At present, what are the things around us, especially the book, the pen, what we are using to write, and in front of you the screen and everything is nothing but a matter. Okay, so anything. If I want to raise the duster, for example, if I'm holding this duster is considered as matter. Yes, children. So when I consider this as matter because it occupies some space. When I place the duster on my palm, so it occupies some space. And I feel the mass. Yes. So when I apply the stress, I can see the object is present over here. So then we can simply say that it is nothing but a matter. And water also. Water occupies the vessel or the container what we have taken. So it also considered as matter. And air is also considered as matter. Gas is also considered as matter. The best example of air, we can't see the air or we can't feel the air. But when it's wind, the force, the pressure, if the air is having so much of pressure, then we can feel that air is there. So when we feel the air is present, when we are suffocating so much, or we sit under the fan and we feel that, okay, we are very much comfortable. Then we can say that air is present over. We breathe the air, we feel it, but we can't see the air. But when you see the mass of air, when we fill the balloon with the air, then we can say that this is the best evidence that air is having some mass. Understood? So this is nothing but matter. Matter can exist in all the three states. Solids, liquids and gases. So I have given all the three. You can see that here images. Is it they are clear now? Books, water, and you can see the air over here. Okay, these are the best examples for matter. And the other one, what we have discussed about the other one, Panchata. So previously the scientists, what they have decided and how they classified the matter, they classified on the 5 fundamental properties or 5 fundamental substances. What are the 5 fundamental substances, children? What are the 5 fundamental substances I have told you? We have discussed about. The first one is air. Yes. So the philosophers, the earlier Indian philosophers classified matter into 5 different basic elements. What are the 5 basic elements? One is air, earth, fire, yes, sky, and water. So based on these 5 things, if it comes under temperature, they consider temperature under 5. Okay, if it is air, they classified under air. Earth, universe, okay, sky, and water. So on these 5 basic elements, the Indian philosophers, previously earlier philosophers, they classified the elements into 5 basic elements. What are they? Air, earth, fire, sky, and water. But at present, the scientists has classified the matter into 2 basic properties. One is physical properties and another one is the chemical properties. In this chapter, we are not going to touch the chemical properties. We are only follow on the basis of physical properties. We just only see the physical properties of matter in this chapter. We are not going to touch any chemical composition of the elements. Okay. So now what are the physical properties in general? Color, yes, color, state, okay, color, state, size, shape, all these simple physical properties by seeing with our eye, with our naked eye, we can easily say that they are considered as this, whether they are solids, whether they are liquids, whether they are in gaseous state. So next one, physical nature of matter. So this physical nature of matter is mainly is further classified into matter is made up of particles. So for this statement, we have given the best evidence. What is the best evidence what we have given for the matter is made up of particles? I have shown you the activity also. We have taken the beaker. Okay, 100 ml beaker. We have taken 50 ml of water in it. Yes. We have added 1 scoop of salt or sugar in it and we dissolved with the help of spatula or the glass rod. We have taken the salt or sugar with the help of spatula and distilled it with a glass rod. When we stirred it with a glass rod, what happened to the salt or sugar? They completely dissolve in the water. Where does this solute go? Where they occupies? They occupies the space. This we have already discussed. Just a recap, just listen, so that this will be a connectivity to the next coming topics. Okay, so the molecules, the water molecules. We have taken the beaker now. In that beaker, we have taken 50 ml of water. Okay, in that we have taken 1 scoop of salt or sugar in it. We dissolved it with the help of glass rod. Is that the level of water increases? Is that level of water increases, children?
No, ma'am.
No, ma'am.
Very good, very good, very good. So, where does this water go? Solute go. So here, if we consider these are the water molecules. What are they, children? Water molecules. These water molecules are present inside the beaker. So when you add the salt will occupy the spaces. The space is called as, the spaces between the water molecules called as
Voids.
Void. They are nothing but very good children. You understood, you followed the topic. Okay, they are nothing but voids, these voids. These voids are filled by the solute particles so that they completely occupy the spaces between the water molecules. So there is no rise in the level of water in the beaker. Understood? Simply we say that the water is completely dissolved in the solvent. Here solvent is nothing but water. Understood? Completely the solute disappears. Does the level of water changes? No, there is no change in the level of water. Why? Because the solute particles will occupy the space between the water molecules. Understood? So this I have shown you the activity also. I think by saying this you got the recapitulation of the activity. Yes? Next. What is the next one? So we have discussed about the characteristics of matter. Okay. So when we have discussed the characteristics of, this is the activity, no? We have taken the beaker containing a few ml of water, spatula, the spoon, which is used in the laboratory is nothing but spatula. Children, if you want to write, please write the running notes, it's better. So that you can read the topics after the end of the class. After class completions, you can once again read the topic. Okay, see the beaker containing water, you have taken the spatula full of salt and we are stirring that what? Glass rod. Okay, why we use glass rod, children? This also I have explained. Why we use glass rod? Glass rod is used to stir the solute and the solvent and there is a homogeneous mixing of solute with the solvent. Yes, so this is the way I have shown you the activity also. Next. What is the next one? Characteristics of matter. Actually, how many characteristics of matter are there, children? First one. First one.
Three.
3 characteristics. Before that, how small are these particles of matter? How small are these particles of matter? So we have done an activity by using potassium permanganate. What is the color of potassium permanganate? What is the color of potassium permanganate? You have seen the activity also.
It is pink or magenta.
Yes, very good. It's pink or magenta in color. Yes, it's pink and magenta in color. So what is the activity? We have given evidence for this. How small are these particles? We have taken how many beakers, children? We have taken 5 to 8 beakers. We have taken 5 to 8 beakers. In first beaker, take 100 ml of water and add one scoop of KMNO4. But in the activity, it is given as 2 to 3 crystals. But to see the dilutions, concentration of the solution, we'll take 1 scoop of potassium permanganate in it and we'll dissolve with the help of glass rod. And take 1 more beaker containing same quantity of water, that is 100 ml of water in it, and transfer 10 ml from the first beaker. And again you can see the dilutions, you can see the concentrations. Alright, this is more concentrated than this. And repeat the experiment for 5 to 8 times. 5 to 8 beakers we'll use, and it is repeated for 5 to 8 times. When we use 5 to 8 times, what we'll observe? We'll observe the gradual change in the dilutions of the potassium permanganate solution. This is that when we see the last beaker also consists of potassium permanganate sample in it. That means the matter itself divide by themselves, it divides into simpler and small particles. Even we can't imagine how much small they divide. Understood, children? So this is the activity. I have shown you the video also. So that's why you can remember that visual effect only easily you can remember the color change. If I say simply the pink and magenta, then you'll be having a question mark. Okay, pink, magenta, what color it is? So I have shown you the activity. So see the then immediately get this thing. What you'll get in your mind? How small are these particles of matter? Understood, children?
Ma'am.
Yes, ma'am. Yes.
Ma'am, what is that small n in KMNO4?
KMNO4. KMNO4, potassium permanganate. The formula for potassium permanganate is KMNO4. It's not visible. It's not visible clearly.
Ma'am, it is visible, but what is that small n for? What element is that?
Yes, very good. I'll clarify this. KMNO4. K stands for potassium.
Potassium.
K stands for potassium, Arna. Is it visible?
Yes, ma'am.
Mn stands for manganese. Manganese. What element it is? It's a compound. Potassium permanganate is a compound. Compound is nothing but a combination of different elements.
Okay.
Combination of different elements. Understood?
Yes,
so,
ma'am.
Mn is nothing but manganese, O is nothing but oxygen. Okay. Whenever we represent an element, whenever we represent the symbol of an element, if it is 2-letter symbol, 1-letter symbol is carbon is 1 letter. Yes, C. If we are representing the 2-letter symbol, first letter should be the capital letter, second letter should be the small letter. Here, Mn is nothing but manganese. Understood, Anna?
Yes, ma'am. Thank you.
Very good. So, KMNO4 is nothing but potassium permanganate. Potassium permanganate, which is purple or magenta in color. Okay. So, the same evidence, we have given one more activity that is nothing but a Dettol. Same activity by the odor, by smell, by strong smell of antiseptic liquid that is nothing but a Dettol. When we are diluting the Dettol from first beaker to the last beaker, even though the last beaker consists of very minute amount of particles, but we feel the odor. This shows that what particles of matter are very small. Yes, the particles of matter are very small. They are small beyond our imagination. We can't imagine it, how small they are. Understood? So immediately we started discussing the characters. What are the two properties we have discussed? Particles of matter have spaces. This is the video I have shown you.